Will it Dubai? That is the question. And what I mean by that is that all these lamps, I'm about to modify things a little bit to make them emulate an interesting lamp available only at the moment in places like Dubai. I think it's available in the United Arab Emirates in general. But it's made by Philips at the request of the King of Dubai. And he wanted a lamp that was super efficient, extra low power, high output, and by quadrupling number of filaments. Say for instance, this is a 2-watt lamp. This is also a 2-watt lamp. This one has 2 filaments. This one has 8 filaments. By doing that, they increase the efficiency, and it means that it puts out a good amount of light, but it runs super cool. And the LED filaments are all really underrun, and they're going to last for ages. But you can achieve the same by devious means, by putting capacitors in series with them, which is the whole point of this experiment. Because many of these lamps are based on capacitive droppers, where the current on each half of the main cycle is limited by a capacitor. And it regulates the current through, and by putting an element in series, you can regulate that down further. Other lamps like this one use a linear current regulator, and it's like an electronic resistor that when it detects a certain level of current, it changes its resistance and it just balances off, and any excess is dissipated as heat into the same platen as the LEDs. But watch this. I'm going to take the exposure off, I'm going to turn the light off, and this lamp here it's a high power lamp. I think it's about 6 watts. It's currently showing 0 watts. It's not super bright, but it would be too bright to be a nightlight. It's the sort of thing that if you put it in a cupboard or something like that, you could pretty much leave it on all the time. It's running at super low power, it's staying super cold, and this has been like most of the lamps are a success. This is what we're going to see. Watch your eyes, the light is coming back. So here's what I'm going to do. I'm going to lock the exposure off for a start so it doesn't yo-yo up and down. What I've got here is the Hoppy power tester, and I've got a socket for the lamps, and I've got a little inline adapter so that I've put a capacitor in series of the lamp. Yes, that is live. I will try not to touch it. I've also at the back put a resistor in parallel as well, 1 megohm resistor. The reason for that is so that when I turn the power off, the capacitor is discharged, so I don't get a little zing off it. So I'm going to unplug this, and what we're going to do, I've made a chart up. We're going to test all these lamps with 470 nano, 220 nano, 100 nano, 47 nano, and 22 nanofarad capacitors. Originally, I thought I was going to have to go higher, but I've not. I've done some tests. It's pretty amazing. That's why I added 22 nano as well. And I've got a whole load of lamps, and then at the end, I just added some more random ones in. But I'm going to disqualify some of them to start off with. So, for a start, I'm going to put the highest value capacitor in. And I'll show you some of the lamps with this, but then I shall pause the video while I do all the other tests, and I'll log it down and we can look at the results afterwards. So this capacitor, well, this isn't the capacitor I want this one. This is the 470 nanofarad capacitor. Note, if you want to do this in America, you'll have to use a higher value capacitor like 1 microfarad. But having said that, once you see the results of this test, you'll probably find that 470 is just fine. So I'm going to plug this in, and the lamp lights at a fairly decent intensity with that. It's now drawing about 2 watts. I'm going to log this because this lamp originally started off, it's 5 watts. This lamp originally started off as 5 watts. It's now drawing 1.8 watts. And as a result of that, it's going to stay absolutely stone cold, and it's going to last a very long time. And yet it's putting out a decent amount of light, because as you underrun lamps, they get more efficient. Now, a couple of lamps I'm going to disqualify straight away have electronic drivers in them, and they're not happy at being put in series with the capacitor. So the first lamp to disqualified is this decorative one. I plug it in, it flicks once, and then it glows very dimly and shimmers and flickers. It's trying to run, but it doesn't like that. So this lamp is disqualified. It won't run on any of the capacitors that I've tried. Out of the way it goes. This disco lamp, and I suppose it varies from lamp to lamp, is also sad. When you first hook it up, it has a wee go at starting, a wee flash. Yeah, you don't even see it. It's not going to do anything. It's not happy. So it is also disqualified. A lot of the lamps disqualified early on are the ASDA 12 watt. The ASDA 12 watt, which gets super baking hot. It's the whole reason that Dubai lamps are such a great idea. Keep in mind, 2 watt, 12 watt, 2 watt, 12 watt. This one has 6 long filaments. It strobes. I should have warned you about that. I should have said, watch your eyes, it's about to start strobing, plug it in, and it's strobing now. See, horrible. The other lamp that does that, there is another lamp, is it the lap 6 watt lamp, I think does that. If I screw this in, watch your eyes, it's going to strobe. It's strobing as well. That's because it's got an electronic supply and it does not like being treated like this. But other lamps, like say for instance the Philips dimmable, is it going to be okay? Yes, it is okay. The Philips dimmable lamp is okay with being run like that. So let's do some tests. Let's bring in the notepad and I'll do the first test at 470 nanofarads, but because that's going to take a long time to do all these other tests, we won't. I'll pause the video while I do all the other tests, and then I'll show you the end results here. So this is the 470 nanofarad. We've already found that the ASDA 12 watts does not like that, so it's void. We've got, what's this one? This is the Philips 4 watt dimmable. We've already proven that's all right. It runs at, it's a 4 watt. It's running at 3.4 watts. 3.4 watts. So not a huge amount of difference. Next lamp. ProElec 8 watt. ProElec 8 watt. The 8 watt, this is another good example. 2 watt, 8 watt. 4 times the rating, 4 filaments, 2 watts, 8 filaments. This is why these lamps do not last a long time, but the ProElec 8 watts is perfectly happy in series with that capacitor and runs at 2 watts. 2 watts. ShopRite, I'm going to have to use the adapter for this one. The ShopRite, this is a, well that's the Maxim. This is a ShopRite that can go straight in. This is a ShopRite. Oh, where is the ShopRite one? That's wrong. Oh, the Maxim was right. I was right. I'm just talking crap here. Just ignore me. ShopRite 10 watt has reduced in power to 1.98, let's say 2 watts. So I'm seeing a common trend here that the 470 nanofarad is reducing most of the higher power lamps to a 2 watt dissipation. And that will run super cool. Normally this lamp gets baking hot, but it will actually run a lot cooler for that and more efficiently. Next lamp is going to be the Holt 5 watt. That's this one. This is a cheap pound shop lamp. It's not Pound Land. This is out of One Below, which used to be Pound World. This is running at 1.8 watts. And that's good because the Holt lamps inside are somewhat minimalist in the LEDs. They're a bit skimpy, and as such, they're not going to have a long life. But running at 1.8 watts, they're going to have a very, very long life. I should mention at this point in time, well, I'll get to that afterwards, but actually, no, I'll mention it now. The Dubai lamp, this 1 megohm resistor in series without any capacitors at all. This was the only one that performed with a 1 megohm resistor in series. It took 20 seconds before it started glowing, but it made a good night light and would last literally forever. Status 4 watt. What's the status? Hold on, that's the Philips. Let's rake through these lamps. I'm not even sure what that is. Status 4 watt. This was from, I think this was from the local Jack's Home Stores. And it's running at 1.8 watts. 1.8 watts again. So it will run cool and it will last a lot longer. The Philips 2 watt. Oh, where's the Philips 2 watt? There's the Philips 2 watt. This will need the adapter. When I plug it in series with 470 nanofarad, it's running at 1.6 watts. 1.6 watts. And will remain super cool and last for ages. Lap 6 watt. This is the Lap 6 watt. Did this one work? I can't remember if this one was this one might be, watch your eyes, this one might be the one that was flickering. it might contain the electronic supply, so it might strobe. So I'll warn in advance, this may strobe. Yeah, it's not happy. So it's going to get disqualified. It doesn't work with the super high power lamps with the electronic switching supplies. However, lap 4 watt. Where's lap 4 watt? Lap 4 watt. It has a simple supply inside, presumably, and is running at 1.7 watts. 1.7 watts. Next lamp is lap 2 watt. That'll be the little, this will be the little candle lamp. Is it going to flicker? Yeah, it flickers. All the candle lamps, they just see it, you can see it flickering. It's horrible. But it's running at 1.5 watts with flicker. Flicker's important. You may not realize this, but your eyes actually only focus on a tiny area that you're looking directly at. If you look directly at, say, the word hold here, then you won't be able to read anything above or below it. You have a very small area that's super high resolution, and it reduces in resolution into peripheral vision. And the peripheral vision has extreme sensitivity to flicker and strobing. That's why flashing LED lamps and flickering LED lamps are a bad idea, because it actually, it's a built-in instinct that when you get that flicker, it attracts your attention to that. It kind of fires an interrupt to your brain and says, pay attention, there's something moving over here. It's just an instinct that's built into humans and other animals. So if that's flickering all the time, that continually stimulates peripheral vision, and that is not a good thing. So flickering lamps are not a good idea. What's the next lamp? Oh, right, okay. Asda GU10. This is a glass 5 watt lamp. I think it's 4.8 watts, but 5 watts. And it lights fine. It puts out a decent amount of light. It's running at 1.5 watts. This visible flicker in the camera, I'm not seeing that flicker here. It's actually pretty good. The camera tends to be more sensitive to that. So 1.5 watts, which down from the 5 watts means that's going to last a very, very long time. The Dooby lamp, the original Dooby lamp, will of course perform flawlessly at that power. It is rated 2 watts. Put it in, this is a cold white one. They like the cold light there. It's running at 1.2 watts. But still putting out a good amount of light. Quite harsh because it's cold white. Some people like cold white. Some people do not like cold white. Next is another GU10 lamp. It's the cheapy pound shoppy type, sort of holty type GU10 lamp. Rated 5 watts. Put it in. No flicker. It's almost certainly using the same circuitry as this, the little linear regulator, so they are prone to a little bit of shimmer. Not visible to the naked eye though, which is good. And it is running at, I'd say 1.9 watts. 1.9 watts. Asda 4 watt lamp. Which is the Asda 4 watt lamp? This one is the Asda 4 watt lamp. The Asda 4 watt lamp lights at a decent intensity and draws 1.5 watts. I should bring this in so you can see it. 1.5 watts. And then mystery 2 watt lamp. Chinesey 2 watt lamp, which means it's almost certainly going to flicker because they always skimp on the circuitry. Is it going to flicker? Yeah, it's flickery. Is it flickery to the eye? It's not actually too bad. Oh, there is a bit of shimmer there. Yeah, not ideal. It is running at 1.1 watt. 1.1 watt. Okay. Right, what I'm going to do now, I'm going to unplug this. And I'm going to swap in first a 220, then 100 nanofarad, then 47 nanofarad, then 22 nanofarad, and then I'll come back and show you the results. So one moment, please. I'm just going to do those tests right now. Okay, I'm on the home run here. We're at the lowest setting. I can't even measure this. I haven't been able to measure below 0.5 watt. Visible, this would look bright as a night light. You know, it doesn't seem much, but well, let me demonstrate. I'll take the exposure off. I'll turn the light off, and you can see, I'll take the exposure off this time, that it actually puts out light you could read by. It's actually a decent amount of light this puts out. It's surprising. Watch your eyes. The light is coming back. The big light. This has been very interesting so far. What's the two lamps I've not yet tested? I've not tested random 2 watt from China, which will flicker, but is lighting. So I'll just put a tick for it. And what is the last one I've not tested? I think there's a couple. I've not tested the ShopRite 10 watt Maxion light, which is this one. 10 watt light running at an unmeasurable, no big delay. Is it going to light? Is it going to light? Sometimes a bit of a delay while the capacitor charges. This one has a resistor, a shunt resistor to stop passive glowing. So this one is apparently not going to glow. That's interesting to note. So this one, which is the Maxim, 10 watt, did not glow. So that's a 0 with an X. It's worth mentioning that I'll show you afterwards. This one did glow. And the final one is the lap 6 watt, which is the one that tends to strobe. Watch your eyes. This probably will strobe. It might strobe it. Is it going to strobe? It's going to strobe almost like, you know, that would be a great effect. That's roughly 1 hertz it's strobing at, so it's not ideal. I shall mark that down till the lap 6 watt has strobed in every single one at decreasing speeds. So, right, I'll take that out. I'll put the Holt cheapy pound shop one in, slight delay, and then it comes up and it glows. Slight shimmer there, but that's just because there's a slight ripple. That was a very interesting test. Let me summarize the results here. The Philips 4 watt dim bulb was quite odd. It seemed to compensate for the capacitor in series. It actually ran at about 3.4 watts for a 4 watt lamp. It was not happy after that. It rapidly, the next, when I swapped down to 220 now, it went down to 1.1 watt, which was fine, but it wasn't very bright at all. That's why it's got an exclamation mark. And then it just didn't want to light for the rest. So it's got active electronics in it. Most of the lamps ran between 1.5 watt, 2 watts on 470 nanofarad. The lap 6 watt strobed. That's the only one that didn't really perform. Every other one, apart from the ASDA 12 watt, which strobed, every other one kind of worked. When I dropped down to 220 nanofarad, the power dropped. Let's zoom down on this a little bit, not too much though, because I'll zoom right off the bottom. I'll keep zooming in and then try and nudge it up like that. Okay. I'll also focus down onto that for extra super sharpness. So 220 nanofarad, everything dropped down to roughly 1 watt. You know, you could virtually say 470 nanofarad, 2 watt, 220 nanofarad, 1 watt for just about every lamp. Notable exceptions, the GU10, the dollar store GU10, they're so simple that it actually ran just slightly above a watt. And as did the Philips 4 watt dimmable. And the cheapy Chinese, the unbranded 2 watt, ran at 0.7 watts. That was probably its little shunting resistor that stops it glowing with switch wire leakage. When I dropped down to 100 nanofarad, some of the lamps displayed 0.5 watts, but most of them just dipped slightly below that, and apparently the Hoppy refuses to read below 0.5 watts. It doesn't regard that as a valid reading. So the Philips just stopped working completely. The ASDA was strobing. All the others lit except for the lap, which was strobing. And the GU10 ASDA lamp started flickering. Oh, there's another thing. The GU10 ASDA lamp, that's the glass one. This worked okay at 470 nanofarad. It dropped down to 1.5 watts, but after that it started shimmering, notably at the every other capacitor. So it only worked at 470 nanofarad. By the time it got down to 22 nanofarad, it just didn't light at all. So that's half watt. 47 nanofarad, the ASDA was not lighting at all. The Philips dimble was not lighting at all. The lap was still strobing. The GU10 ASDA lamp was doing its flickering, so not really good. But every other one glowed at slightly different intensities, but all glowing, usable as a bright night light. At 22 nanofarad, I did not think any of them were going to actually go down this low, because that's a tiny value of capacitance. It's almost like wiring leakage. 22 nanofarad, the ASDA lamp wasn't working, the Philips 4-watt dimmable wasn't working, the ProElec 8-watt lit, ShopRite Maxion did not light at that one, the lamp was strobing at its 1 hertz, the GU10 ASDA wasn't working at all, everything else worked and just glowed at a gentle level. That's very impressive. That is very, very impressive. So what I'm taking away from this, if you want a decent effect, in the UK, 470 nano to 220 nanofarad is going to give you a decent bright light. If you want to get it down to sort of like nightlight levels, you're going to have to go to 47 nano or 22 nanofarad. It's worth checking the lights. Some of them at 22 nanofarad took a while before they actually faded up. This is good. That means they've got a smoothing capacitor in them. And it took a while to charge that gradually up until the LED's lit. That means there's not going to be much ripple, no flicker, which makes it excellent as a nightlight. In summary of the circuit, I'll just flip this page over. In summary of the circuit, all I did was, where I had instead of the live going straight to the lamp, and then going back to the neutral, all I did was interrupt. Well, in this case I interrupted the neutral for safety, but you know, you could uninterrupt the live as well. Stick the capacitor in series with the lamp. This time I'll write it properly. Lamp, back to neutral. And I put, just for safety for my test, I put a 1 megohm resistor across that. It won't actually see a terribly high voltage. It's optional, but it means that if you're messing around swapping capacitors, make sure you basically, when you unplug them, just get some metal and short the leads. Otherwise, you might get a little snap off the capacitor because it holds a charge. But the summary is 470 microfarad, and double this if you're in America, because that's roughly going to be equivalent, I think, was equal about, turned most lamps into a 2-watt lamp. 220 nanofarad. Oh, nanofarad, don't put 470 microfarad, that's not going to have an effect. Was turned them into roughly 1 watt. 100 nanofarad was roughly 0.5 watt. And before that, below that, 47 and 22 nano, unknown, nightlight. A nightlight that will last literally forever. This also means that if you had the light switch in the room, say there's a light switch that switches the light on and off, and you put this little capacitor across that, it means that you could have a full brightness light during the day, but at night time when you turn the switch off, the capacitor would just trickle. Say use 47 nano or 22 nano. It would trickle just enough current across for many lamps just to make them glow at night, just for that extra sort of level of comfort in the room. And that capacitor, you could do something like, you could sleeve it and tuck it behind the light switch itself with a couple of wires attached, maybe soldered on, or even just some sleeving and then just bridged across the contacts. You don't have to worry too much about these blowing up, these capacitors, or failing dramatically, because they're in series with a current limiting device, the lamp itself. But there we go, that was very interesting. So the answer is, can your Dooby lamps, can you turn them all into a Dooby effect where they're underrun and slightly more efficient, but running cool and will last for a very long time? And the answer is yes. All you need to do is add a capacitor in series, and by adjusting the value of the capacitor, you can get different sort of levels of intensity. You can fine tune them to exactly how you like your light. So this test was fun, and it was a success, and there's even some wine left to drink after the experiment while I tidy up. That was a fun project. I really liked making this video. That was good.